So hello all, I'm very happy to have you here all. My name is Dikla Feingertz, and as the Quality Management Team Leader at PlaxidityX, I lead our ASPICE and ISO 21434 processes, while actively researching the evolving landscape of automotive legislation. Janine?
Yes, also a very warm welcome from my side. I'm Janine Funke. I am from US Solution and leading the strategic area cybersecurity there. So I'm responsible for business development, but also consulting and coaching our clients for automotive cybersecurity and also the broader scope on industries, and also part of ISO delegation and working groups. Happy to have you here in this webinar.
Cybersecurity compliance can feel like a maze, especially in our interconnected global landscape. We are facing a complex compliance landscape defined by diverse global cybersecurity regulations. Each framework, from ISO 21434 to regional mandates like EU Cyber Resilience Act, brings extensive documentation and specific processes. Taking an isolated approach to each one leads to significant duplicated efforts and create challenging documentation puzzle. This isn't just inefficient. It results in audit and assessment fatigue. The sheer number of audits and assessment required for different standards and regulations severely strains our resources. So what can be the approach? Identifying the common ground among various standards in the basis of diverse driving efficiency. This allows us to integrate our processes and systematically reuse documentation, simplifying compliance effort. Okay, so let's overview the regulation and the standards. Manufacturers must adhere to regulation in every country where they sell vehicles. Around 16 countries are set to implement the WP29 regulations, establishing the fundamental basis for automotive cybersecurity. WP29 is the global form setting mandatory homologation requirements for vehicles, including cars, trucks, and buses. This includes critical regulations on cybersecurity, such as the UNR 155 and UNR 156. UNR 155 is a global mandate requiring vehicle manufacturers to implement a cybersecurity management system, also called CSMS, across the entire vehicle life cycle, from development to post-production. As a prerequisite for type approval. This ensures the continuous cybersecurity of road vehicles. UNR 156 is another global regulation establishing requirements for software update management systems. It ensures that all software updates, whether over the air or physical, are secure and safe throughout the vehicle's life cycle, preventing unauthorized modification and maintaining vehicle conformity. Let's view the essential international standards and industry frameworks. Those ensure robust secure development practices across the globe in the automotive industry. ISO 21434 is an international standard, provides a framework for managing cybersecurity risk in road vehicles throughout their entire life cycle, from concept and development to production, operation and decommissioning. Its primary goal is to establish robust cybersecurity process and ensure security by design within the automotive industry to protect against cyber threats. We also have ISO 5112, and this standard is actually providing a guidelines for auditing cybersecurity for ISO 21434. It's outlining how to assess an organization's cybersecurity management system. ISO 24882 is under development currently. This is the agricultural machinery, tractors, and earth-moving machinery for cybersecurity engineering. This is emerging standard and crucial for bringing cybersecurity best practices to the heavy machinery sector, ensuring alignment with broader regulations like Cyber Resilience Act. And also we have the ASPICE. This is a framework used to assess and hardware processes. It provides a structure and maturity level of automotive software. Okay, let's move to China. So China has GB 44495 2024, which is the technical requirement for vehicle information security. This is a mandatory national standard, sets out comprehensive cybersecurity guidelines for the automotive sector. It is heavily influenced by international standards like UNR 155 and ISO 21434, but it includes also a specific requirement tailored to the Chinese market. We also have GB 44496, which is the general technical requirement for automobile software upgrades, and this standard is similar to UNR 156 and sets the requirements for software update management system to ensure secure management of auto and software updates. It mandates pre-upgrade notification and change approval for update affecting key parameter. Okay, now we will review the European Union. So in the European Union, we have the NIS2 directive. This is the EU-wide cybersecurity regulation that expands the scope of critical sectors and entities required to implement robust cybersecurity measures. It mandates a stricter risk management practices, incident reporting obligations with specific timelines, and holds top management accountable for that. It is an organizational level and protects the company. The CRA, which Janine will emphasize later, I will just say that this is the European Union formally adopted product level regulation on October 10th, 2024. We also have the EU AI Act, which is linked to the Cyber Resilience Act CRA actually. They are interlinked in scope and compliance expectations, especially for high-risk AI systems that also fall under the definition of digital product with the CRA. So here I will just want to say that you need to have a heads up for that, because the enforcement is already in progress, and part of it will come into force in the upcoming month, and the fully applicable will be in 2026. Moving from European standard, let's turn our attention to the United States approach to automotive cybersecurity, which involve both vulnerability guidelines and emerging supply chain regulation. First, we have NHTSA cybersecurity best practices. It covers cybersecurity issues across all motor vehicles and mobile applications, guiding all individuals and organizations designing or manufacturing vehicle electronic system and software. Its broad applicability includes vehicle OEMs, Tier 1 and Tier 2 suppliers, manufacturers, modifiers, and others. Next, a very significant development. This is a very new one, the securing the information and communication technology and service supply chain. This is regarding about connected vehicles, which has a pivotal effective date of March 17, 2025. This will directly target national security risk posed by connected vehicles. Specifically, it prohibits the import of the sale of certain vehicle connectivity system, hardware, and software in connected vehicle. The prohibition applies if those components are designed, developed, manufactured, or supplied by entities owned by, controlled by, or subject to the jurisdiction of direction of China or Russia. This action by the US Department of Commerce, BIS, underscores a strong focus on supply chain integrity, aiming to prevent foreign adversaries from potentially compromising our transportation ecosystem. Now, we've just heard a lot about our rapidly expanding world of automotive cybersecurity regulation and standards. This slide, with its visual map, is designed to illustrate a crucial point: the significant overlap that exists between key frameworks like ISO 21434, ASPICE, and the EU Cyber Resilience Act, which is also being called CRA. In the next slide, we will dive deeper into one of these pivotal regulations we just mentioned, the EU Cyber Resilience Act CRA. The key elements directly impacting product development and market placement. First and foremost, the CRA introduced mandatory cybersecurity requirements for placing products with digital elements on the European market. This is a significant shift. If your product contains digital components, it must meet security benchmarks to be sold in the EU. These are cybersecurity essential requirements that span across the entire product lifecycle, from design to the end of its lifecycle. The holistic approach mandate principles like security by design, vulnerability management processes, incident reporting mechanism, SBOM, and ongoing product support and update throughout the product lifespan. The CRA also clearly defines obligations for manufacturers, distributors, and importers. Everyone in the supply chain is responsible for ensuring product security. Finally, the Act introduced differentiated conformity assessment methods depending on the product category. This means the rigor of the assessment will vary based on the perceived risk level of the digital product, ensuring a proportionate approach. It is important to note that failure to comply with the CRA can result in financial penalties, fines up to 15 million or 2.5% of the company's worldwide annual turnover. In this part, I will hand over my presentation to Janine.
Yes, thank you, Dikla, for introducing what we are dealing at the moment with this regulatory landscape and also introducing the Cyber Resilience Act. So you may ask yourself, okay, what about the scope for the automotive industry? And yes, it is highly discussed. So basically, the EU Cyber Resilience Act is excluding several regulations. But I'm saying regulations because at the moment, a lot of people say, okay, some industries are excluded. That's not right. There are no industries which are excluded. There are only regulations which are excluded. And we have to take a closer look what exactly is excluded from those regulations within certain industries. So first, I would like to start with the General Safety Regulation, because the General Safety Regulation, which is a road vehicle type approval for the vehicle categories M and N, here and N, this is excluded from the scope from the Cyber Resilience Act. And basically, this regulation is important because it implements the UNR 155, which Dikla already mentioned. There's one differentiator. So normally the General Safety Regulation covers the vehicle categories M for passenger cars and for commercial and O for trailers. But the EU or each member of the UNECE is free to adjust a little bit the scope. And therefore, at the moment, the General Safety Regulation does not apply vehicle category O for cybersecurity, meaning UNR 155 is not applicable for vehicle category O within the European Union. That, as a consequence, the vehicle category O at the moment would fall under the Cyber Resilience Act. As the Cyber Resilience Act is also discussed, so we will see in the future if it will be also excluded from the Cyber Resilience Act and shift to the General Safety Regulation or vice versa. So this question is still open. Then we have another topic, which is vehicle category L. So you may notice that vehicle category L was recently included within the scope of the UNR 155, meaning it was included within the regulation EU 168/2013. And this is the one which is important for the approval and market surveillance of 2- or 3-wheel vehicles and quadricles. But we have one special situation here. The EU Cyber Resilience Act with the Article 68 already amended the EU 168/2013, meaning at the moment we would have a double regulation here. But the vehicle category O was a vehicle category L, was just recently included within the UNR 155 scope, and the text or the regulation from the Cyber Resilience Act is a little bit older. Therefore, it is definitely expected that here there will be a change also within the Cyber Resilience Act text, and then we would have only category L cybersecurity within their own type approval regulation. For a completeness reason, I also mentioned here other non-automotive regulations because this General Safety Regulation is not the only one which is excluded from the Cyber Resilience Act. We also have other topics from aerospace and also medical which are excluded from the Cyber Resilience Act. Another question is the automotive supply chain. So what about the automotive supply chain? This is not finally discussed because the General Safety Regulation actually applies to OEMs and not suppliers, but the current understanding is the following. So if you have a type-approved digital component, it is excluded from the Cyber Resilience Act. But it really means your component from a certain supplier needs to be also part of the type-approved vehicle. For example, there are other parts like aftermarket part, retrofit parts, and also some non-type approved digital components. And if they are placed on the market separately, they are not excluded from the Cyber Resilience Act, and then they would fall within the scope of the Cyber Resilience Act. Another topic is also that within the automotive industry, we are not only dealing with vehicles, we have an ecosystem, we have charging infrastructure, and also you're, for example, using apps to navigate your car. So there's more than just a vehicle within the automotive industry, and therefore a lot of products with digital elements around the vehicle are falling within the scope of the EU Cyber Resilience Act. And now this was only about vehicle categories M and L. What about the other vehicle categories? Dikla already mentioned that there's a new ISO standard coming up, which is the 24882, which is dealing with agriculture and forestry. So actually, they also try to align this ISO standard with the Cyber Resilience Act, because the agriculture and forestry and also off-road vehicles, you can see it here on the left side, T, R, S, and G, they actually will fall under the Cyber Resilience Act. And therefore, it is important that their ISO standards is actually aligning with the EU Cyber Resilience Act. So you see, the scope and the applicability for the automotive industry is still a little bit unclear, but it is expected also with the new ENISA guideline, which will come up in the next month. There's more clarity also on the scope of the automotive industry. But this, what I just explained, is the current understanding the industry has, which was also discussed within the last weeks on conferences. So I had some discussions about that. So, as ISO 21464 is one of the main regulations Dikla already mentioned within our industry, it makes sense to have a look what are the overlaps here. So basically, all the cybersecurity regulations are building upon a risk management framework. So mainly upon the ISO 31000 series, which is describing the risk management. And therefore, we have a big overlap in the basis for all basically regulations which are dealing with risk management and also cybersecurity. So what is similar between those regulations is that the ISO 21464 and the Cyber Resilience Act, they're both covering the complete life cycle, not only until the SOP, really until the product is decommissioned. And also you need to have processes and policies in place to implement your specific regulation. Another topic which is required is also security by design. So both regulations require you to take into consideration security from the beginning until the end. If we are looking at the risk assessment here, it's a little bit different. So the ISO 21464 is actually, or has actually mandatory elements for the risk assessment and its steps. If you are familiar with the ISO 21464, the TARA has certain steps which need to be followed. Actually, within the Cyber Resilience Act, there's no specified method, meaning if it is the case that the TARA would be also applicable for your product, then you could also use the TARA method. But we have some specialities we need to take care of. One speciality is that you need to view the risk in relation to the health and safety of the users. Another speciality is that the risk assessment is not only about the product risk. The risk assessment must also ensure compliance with the essential cybersecurity requirements, which are actually listed in Annex 1 from the Cyber Resilience Act. And this Annex 1 is also taking into consideration some organizational or compliance aspects of risk. Another topic is also within the Cyber Resilience Act, it mandates that you need to be early with the risk assessment. So you need to take the outcome of the assessment into account during the planning, design, during every phase, but really also within the planning phase. Within the ISO 21464, nobody forces you to start with the TARA at the very beginning. But here from the CRA, you need to do the risk assessment from the beginning. Then end-of-life consideration. For the ISO SAE 21464, there's actually not really a support period specified, where some people in the industry are quite happy and some are not. So there's the rumor, I would say, about the 15 years, which we are having in the automotive industry. And it only says you need to have like an end of cybersecurity support declaration, and you also need to take care about the decommissioning. If we're looking at the Cyber Resilience Act, here we are more specified with the regulations. So it says that you should have a support period, which is no less than 5 years. And they give some, I would say, exclusions. So if you have a justification that your component, for example, has a lifetime which is less than 5 years, they are mentioning some pandemic products, for example, in the regulation, then it can also be less than 5 years. But to be honest, this justification is very hard to get. And then you need to specify the end date at the time of your purchase. So when you buy the vehicle, you do not know at the moment when will be the end of cybersecurity support, and it's also not specified within the ISO 21464. And also there are more strict documentation requirements, for example, that you have to keep the technical documentation, user manual, updates available really for the customer, that the customer knows where I can find it on the website, and the updates at least for 10 years after the placement on the market. So here they are very specific. If we are looking at other topics, we have the software bill of material. From the ISO 21464 perspective, I would say it's implicit mandatory because it's an enabler to do vulnerability management and also incident handling. In the Cyber Resilience Act, it's really specified that you need to have a software bill of material, and in best case also share it within the supply chain. From ISO 21464 perspective, for vulnerability management and incident response, we have the basics definitely within the ISO standard, but the Cyber Resilience Act is even a little bit more specific. For example, you should notify actively exploited vulnerabilities or any severe incidents to the ENISA and the national CSIRTs. So here there's also an organization listed within the Cyber Resilience Act regulation where you have to report to, but they did not yet set up the whole infrastructure for that. And also you have to send an early warning within 24 hours, and then a vulnerability or incident notification within 72 hours, and a final report no later than 14 days for vulnerabilities and no later than 1 month for incidents. So actually, the same deadlines could be also implemented within the cybersecurity management system from 21464 perspective, but the 21464 does not mandate any specific timing. So you are free to decide it by yourself. Either way, it's 24 hours or something like that. And of course, you do not have like the national CSIRTs where you have to report to. Conformity assessment and audit. Here it's a little bit different. So we are having here the organizational level and the project level from the ISO 21464 perspective. You have to do a cybersecurity management system audit on organizational level, and there's also no third party required. So the minimum requirement is to do an internal audit. I know that a lot of industry stakeholders require a certificate, but actually that's because of the industry and not because of the standard. And then on project level, you need to do a cybersecurity assessment for the product, if applicable. So cybersecurity assessment is not mandatory, but highly appreciated in that sense. The Cyber Resilience Act has a different view. Here it really depends on the product category, if it's default, important, or critical, and there are differences if you need to do then a self-assessment, if you need to have a third-party conformity assessment, or for critical products you even need to go with a EU certification scheme. So here it is different. And lastly, the supply chain and how you manage the supply chain is both emphasized in the ISO 21464 and also within the Cyber Resilience Act. So now ASPICE comes into the game. So where can ASPICE support? And here we did a comparison with ASPICE 4.0. Basically, ASPICE is a framework which can help you to structure your product development quite nicely and delivers a lot of basics where the ISO 21444, for example, or also Cyber Resilience Act can build upon. Because if you have a mature product development process, then you can add cybersecurity into it quite easy, and also safety, for example, in the automotive industry is also easier to add if you have a mature development practice. So the organizational cybersecurity management system, for example, is supported by MAN 3, the project management, but only with capability level 3. So remember, you have to have a cybersecurity management system. That means governance from the organizational level to the project level, which means you have to have standardized processes which are needed to be lived then within the projects. Also project-dependent cybersecurity management, and there are very good best practices within MAN 3. Distributed cybersecurity activities. Here, the ACQ extension is covering also topics about supplier capability or needs you to align the responsibility. And also the continuous cybersecurity activities are supported by ASPICE, for example, with problem resolution or also configuration management, because without a proper configuration management, vulnerability management and incident management is not possible, because you do not know where you have to vulnerability within which baseline. And in general, all the product development processes from concept phase to the testing phase are supported by CIS and SWE processes. And also for validation, we have an own process area, which is the VAL area. The only thing where we have a little bit weak support is for the post-development phases, because there are not really best practices available from ASPICE, because ASPICE is mostly covering the product development until the SOP and not really looking until the end of life when like the product's in the field. And also we have not really a support or a best practice which we can take over for the clause 15 about the threat analysis and the risk assessment method, because the risk management which is explained from cybersecurity does not go into the deep technical analysis. Therefore here we would not have like a good basis or like best practices where ISO 21444 can build upon. So now let's bring it all together. So we were talking about the Cyber Resilience Act, the ISO 21444, and ASPICE. So basically, we see that a lot of topics are covered from the ISO 21444 and the Cyber Resilience Act. But the Cyber Resilience Act is more specific in certain topics, meaning if we are now in the automotive industry, you have already implemented ISO 21444. And now, in addition, you are Cyber Resilience Act relevant, your product. And then you need to be a little bit more specific in the risk assessment, as I explained, in the end of life consideration. We really need to have a specified SBOM, and you need to take into consideration more deadlines from the vulnerability management and incident response, and do also other conformity and assessment audits. Automotive SPICE can support the complete lifecycle considerations and the processes, basically with all ASPICE processes, because it's about having the right processes in place for the product development. Also, security by design is supported by a lot of processes, or I would say best practices for security by design can be found with a lot of processes. End of life consideration, as I said, here we do not really have a guidance for the SBOM with sub 8 vulnerability management, incident response. Here also problem resolution is a good basis where we can take over best practices. And from the conformity and assessment point of view, also within MAN 3 and the project management, it needs to be planned, and supply chain is then ACQ. Okay, now we were talking a lot about theory, And this was also our main part, saying, okay, we are mapping and analyzing each of those requirements and trying to bring them all together and to see where are the overlaps, that we really do not need to invent the real new 3 times. So one practical example, how could it work? Sub 9, actually problem resolution, can be a good basis for vulnerability management and incident response, because Sub 9 actually requires a systematic problem identification, and this can also include cybersecurity vulnerabilities, for example, and incidents and vulnerabilities can be also added as problem types from an ASPICE perspective, and for those problems types, we need to add then more specific cybersecurity analysis. Basically, it also defines a structured process, which is also needed from an ISO 21444 and CRA perspective, and it also mandates you to log and track your problems and to also have a traceability. It also includes the verification of the problem resolution, or it could be also the incident or the vulnerability, which is also in line with ISO 21444 and the Cyber Resilience Act. And it also supports stakeholder communication. And as we learned, this is also an important part from the Cyber Resilience Act and the ISO 21444, with whom to communicate along the supply chain, but also with stakeholders from national CSIRTs or also from ENISA. And basically, then we have the CRA specifics, where you then have to live according to the CRA deadlines. So if you're doing the problem resolution process and your Cyber Resilient Act relevant as a product, you also have to have stricter deadlines with the 24 hours, 72 hours, and 2 weeks, which I already mentioned for vulnerability and incident management. And therefore, ASPICE here builds a basis, and then on top of ASPICE, you can integrate the special requirements from the ISO 21444 and from the Cyber Resilience Act, and at the end have one process and also one subset of work products, which can be compliant to several requirements or standards. So either way, you do it within a right tool, where you then guide the user more or less to the right tree branches, if relevancy for ISO 21444 or the Cyber Resilience Act is applicable, or also within work product templates have then specific sections which need to be filled out if a specific additional requirement from those standards is applicable. So what do we want you to learn, or like key takeaways from Dikla and my side for this webinar? So basically what you need, because it could be that you are a company who is working industry agnostic or working for several industries, but your product just has like a few changes here from industry to industry. Basically, we are suggesting you to have a product CSMS, a product cybersecurity management system. And here the term cybersecurity management system is just taken over from 21444, but actually here we would like to use this term with a broader perspective. So basically, you should have a product lifecycle, which can take into account ASPICE as quality management, and also quality management is the basis for good product development as a basis where you have structured processes. And then based on this product lifecycle, you shall cover all the different industry requirements or also regulation requirements within one product cybersecurity management system, that you have a governance on organizational level, the product cybersecurity management system, and the basics are the same. And if you have then specifics from ISO 21444 or Cyber Resilience Act, then you grab them into your process. And at the end, the user or the developer shall not notice if there applying here ISO 21440 or the Cyber Resilience Act, they are guided through the product development process without noticing compliance, just seeing, okay, I need to do this and this step. If I did at the beginning my analysis right, if I'm, for example, CRA or ISO 21440 compliant. And with that basis, you can then also have integrated assessments, because you then look at your work product once and use this output, I would say, from the assessments also for several other assessments. And you would have then also a smart tooling in place which can follow the life cycle processes. So that is what we imagine here, because we see there are more and more regulations coming, and actually we need something governed, a product cybersecurity management system, which is then taking into consideration all the different requirements and standards. And at the end, and this is why we also wrote Standard X here, it's similar. This analysis can be done in a similar way also for other standards. So Dikla explained very nicely that we have a lot of different regulations. Also China, the GBs for the cybersecurity in automotive, they require specific testings. And here you could also add another standard, trying to integrate that here with your product lifecycle and your product development. And with that, we just want to take 1 second to explain actually where we are working a little bit more about our companies before we are jumping to the questions. So basically, I'm coming from US Solution, which is which is now having a brand, Software Intensive Systems. And this brand is coming from 3 former brands, which is Kugler Mark, where I was from, KVA and Method Park. So now we are under US Solution, and we are doing consulting, assessment, and also another department is doing certification for different industry standards in cybersecurity, but not only cybersecurity. And with that, I would like to hand over to Dikla, who is telling you a little bit more about PlaxidityX.
Yeah, thank you, Janine. So I'm from PlaxidityX. We are all about automotive cybersecurity. We founded over a decade ago, and we have offices in major automotive hubs worldwide. Probably you may know us as Argus in our previous name. We have a deep automotive cyber domain expertise. Our researchers have been helping automotive manufacturers for years with pen testing, compliance with regulations, and anything cyber related. OEMs and suppliers trust our automotive-grade embedded intrusion detection and prevention product to protect over 70 million vehicles. Thank you. Goodbye.
Thank you so much. Goodbye.